magnetic field generated by a current carrying conductor. Group members in this project are Mahdi Mohammadi, Robert Valencia, Alejandro Vasquez, and Calvin Way. Magnetism, a brief explanation. Electric current is defined by the rate of change of electric charges, primarily electrons. Whenever there is a motion of charged particles, they produce an electromagnetic radiation. The radiation, in effect, sets up a magnetic field around the path of the charge. This is typically done with an AC power source, since the path of the current can be variable. The theory behind the origin of the magnetic field set up by a current carrying conductor can be explained by this phenomenon. Theoretically, the field lines are such that they form concentric circles around the conductor's path. Measurement of the magnetic field reveals that the strength of the field gradually reduces as we move away from the conductor. Now, this could be due to varying effects. It could be due to the number of loops present within the conductor. It could be due from the charge of the AC power source that is moving along the circuit. And it could be from interference from other objects that are producing EMFs. The Biot-Savart law is interesting. The two physical theories that dictate the origin of the type of magnetic field are the Biot-Savart law and the Ampere law. Biot-Savart law establishes the following relationship with the magnetic field due to current carrying segment. The total magnetic field is the sum of the vector at any point within the EMF, also described as the superposition of the EMF. In either expression, R can be interchanged with the number of loops within the circuit as represented by N, depending on the strength of the power source and the series one is running. This equation is also used to denote the forces of the magnetic field and how they affect the charges flowing within the circuit. The thumb rule, which is present within this equation but using different variables, is best explained by how the right hand, the first three fingers, the thumb is going to be the velocity of the charge. The B variable is going to be the magnetic field. And the F is going to be the force that is expelled from that magnetic field and acts on other objects within the circuit. The equation F equals absolute value of Q times velocity times the B value, and taking the cosine of the alpha angle on the first loop can be used to calculate the force of the electromagnetic field. The magnetic field expression, the Biot-Savart law is the full equation used to describe the strength of the magnetic field. R value is the total radius of the coil running from one loop to the wire to the other. When using this calculation, it's important to remember that the total radius has to be known in order to properly calculate the strength emitted from the EMF. U naught in the equation is the free space permeability when running the EMF and is better described as being directly related to the current that is running through it. The I is the strength of the current in amps. The right-hand rule. The magnetic field uses the right-hand rule due to the counterclockwise motion of the EMF and its rotation. The circular motion is due to the charged particles running from the positive end of the diode to the negative end. In order to achieve this effect, however, the power source supplying the EMF has to run on the AC current. The AC current is different from the DC current, in which the voltage from the power source is not linear and constant. In AC current, the power can run forward and backwards, creating that circular magnetic field that is described in the right-hand rule. Finally, we come to the experiment conducted. As observed in the picture, the green arrows indicate the rotation of the magnetic field as described by the right-hand rule. The blue arrows indicate the direction or the magnitude of the electrical current. The battery is wired in series with a loop emitting the EMF. The electric current will flow from the positive end of the battery to the negative end of the battery, creating a complete diode. Reason for the right-hand rule is to visually show the nature of the EMF with the curl of the fingers going in the direction of the magnetic field, while the thumb shows which direction the electrical current is traveling from one end of the diode to the other in the series. This is as described in the previous slide, describing the point of the three fingers. Thank you.